Jai Hind to everyone and good morning to all. I am going to discuss state space variable model in this lecture. So before discussing this state space variable model, you should know the how to draw the state, how to draw the signal flow graph and how to find the transfer function from the differential equation. It should be clear to you, and once the differential equation is given to you, how can you get the transfer function, and if the transfer function is given to you, how can you draw the signal flow graph? So it should be known to you. This is the prerequisite for this, and matrix is also the requirement from the mathematical point of view. You should know how to solve the matrix and how to get the eigenvalues and eigenvectors from the given matrix, and you should also know how to find the rank of a given matrix. So these are the prerequisite for understanding the state space variable model. Now what is a state space model? This is a mathematical model that connects the input, output and internal variables of the system, that is called the states, and these input, output and internal variables of the systems are related by the first order differential equation. This state space model came into the existence during 1960s, and this domain of design referred as modern control design. When the basic law of physics applied to the system will get a set of differential equations, and these differential equations shows the dynamics of the system. So you can say that the state of a system refers to the past, present and future conditions of the system. State space model is nothing but a representation of dynamics of the system in the form of set of n first order differential equation, and it converts the nth order differential equation which governs the dynamics into n first order differential equation. So you can say, if the differential equation is given to you, how can you identify the number of states available in the given model or given system? So the number of states will be equal to the order of the differential equation. If I am talking about the electrical system, then the number of energy storing element will give the information about the number of states. So if the differential equation is given to you, you can easily find the number of states. Number of states will be equal to the order of the differential equation, and if the electrical network or electrical circuit is given to you, then you can see by identifying the energy storing element, you can comment on the states of the system. What are the terminologies that we will use in a state space variable model? So first is the state, second is state variable, and third is the state vector. So state is nothing but it refers to the smallest set of variable whose knowledge at t is equal to t naught together with the knowledge of input for t is greater than or equal to t naught gives the complete knowledge of the behavior of the system at any time t is greater than or equal to t naught. So we can define the states that the small set of variables which whose knowledge at t is equal to t naught together with the knowledge of input t is greater than t naught gives the complete knowledge of the behavior of the system. State variable refers to the smallest set of variable which help us to determine the state of the dynamics, or you can say dynamics of the system, and the state variables are defined by x1 t, x2 t, up to xn t. State vectors are nothing but the state variables that are given in the form of the vectors. So you can say that the state vectors, the variables that are in vector form is known as the state vectors. In state space analysis, we are concerned with three types of variables that are involved in the modeling of the dynamic systems, that is input variable, output variable and state variable. So if I am talking about the system, in any system there are one input and one output. So in dynamics of the modeling of the dynamics of the dynamic systems, we can consider multiple input and multiple outputs, in which input is dependent on the output as well as on the state variables. Suppose this is the system in which n input variables are there, m input variables are there, that is u1 to um, and n state variables are there, x1 to xn, and p output variables are there, that is y1 to yp. So we can define the state variable like in mathematical form: x dot is equal to ax plus bu, y is equal to cx plus du. So equation 1 is for state equation x dot is nothing but the derivative of a state variable, and y is nothing but the output. So we can define the state matrix, state equation: x dot is equal to ax plus bu, and output equation y is equal to cx plus du. But what is a, b, c and d? It has been already shown in this figure that there are n state variables, m inputs and p outputs. So what is a? A is nothing but a system matrix with n cross n. So this n depends on the number of state variables used in the system. So size of the matrix or order of the matrix will be decided from the state variables, number of state variables used in the system. So in this figure you can see that there are n state variables, so the system matrix will be of n cross n. Input B is nothing but the input matrix. Input matrix is of size n cross m, where m depends on the number of input variable used in the system. C is the output matrix, and C is of size p cross n, and p depends on the number of output variables used in the system. And D is nothing but the feed forward matrix, and the order of the matrix is p cross m. Size of the matrix will be p cross m. Now you can write like this: x dot is equal to, we have already seen that x dot is equal to ax plus bu, y is equal to cx plus du. So you can see in this equation, and you can write, you have already seen that A is nothing but system matrix, and this is of n cross n size. B is the input matrix which is of n cross m size, and C is the output matrix which is of p cross n size, and D is the feed forward matrix which is of p cross m size. So you can write here x is n cross 1, u is m cross 1, this is u is nothing but the input, x is nothing but the state variable, and u is again here m input. So you have already seen number n is the number of state variable, m is the number of input variable, p is the number of output variable. So if I want to draw the model of this, block diagram or model for this, you can draw. First we have to draw the model for this state variable or derivative of a state variable, or you can say that this is the state equation. X dot is equal to ax plus bu, ax forgetting, x dot t is equal to ax plus bu. So for getting, first of all we have to identify what is the input and what is the output. Input is, you can see from this model, input is u, output is y. So input of this block diagram will be u, and output of this block diagram will be y. So what is x? X is nothing but the state variable. For getting this, what I want x dot is equal to ax plus bu, x dot is equal to ax plus bu. B is, u is the input. By multiplying by b or gain b, you can get bu as the output of this line. But we want output as x dot is equal to ax plus bu. So for getting ax, we have to add this. So for getting x xt from this x dot t. We have to integrate this one time for getting this xt. So I have used here one integrator. After integrating this, I will get here xt. So by taking the feedback, positive feedback from this output, this is the output of integrator. X dot t is passed through an integrator. After passing through an integrator, we will get here xt. So what will be the output of this? This will be axt. Here I have used the summer. Summer will add these outputs. So what will I get here? X dot t is equal to axt plus but. So this is the desired output. Now we want y is equal to cx plus du. For getting the y is equal to cx plus du, what we will do? We will multiply this c by xt. Cxt will give the y is equal to cxt, but the desired output is d into u. So what we have to do? We have to make a forward branch from the input u. So I have taken a branch from here and I have to multiply with this gain d. So I will get here du. So what will be the output? Output will be equal to cx plus du. In this way we can make the block diagram of this state equation. So it is clear, number of state variable, n represents the number of state variable, m represents the number of input variable, p represents the number of output variable, and a, b and c, a is the nothing but the system matrix, b is nothing but the input matrix, c is nothing but the output matrix, and d is nothing but the feed forward matrix. So you have to remember these, what is a, b, c and d, and what is the size of these matrix. A is size of n cross n, b is size of n cross m, c is the size of p cross m, and d is the size of p cross m. Now how will you represent these equations? This is nothing but state equation. X dot t is equal to axt plus but. This is state equation. Yt is equal to cxt plus dut. This is nothing but output equation. So it is clear that x dot t is nothing but the function of xt, ut and xt and xu and t. So you can write here x dot t is nothing but the function of x, u and t. Similarly, you can write y is equal to cxt plus dut. So again it is clear from this, y is again the function of x, u and t. So both the equations, the state equation and output equations, is function of input, state variable and time. Now let us take an example of mass spring damper system, in which I would like to discuss how will you make the state diagram from this mechanical system. So before solving this question, you should know how will you get the differential equation from this given mechanical system. So for getting the the differential equation from this, you can use two methods. Either you can make the free body diagram, or you can use the nodal diagram that I have already discussed in this force voltage analogy and force current analogy, analogous system in unit 1. So how will you draw this? I have already discussed. First you have to identify number of displacement. Number of displacement will be equal to the number of nodes, and you will also consider the principal node. So number of displacement is 1, so I will consider here only one node. So I have considered x. Direction of force will always be towards the node. So direction of force will always towards the node. So you have to make the force F, and that direction of force will be towards the node. Add the mass element between principal node and reference node. So M1 will be connected between principal node and M will be connected between principal node and reference node, and rest components will be connected as it is connected in this figure. So B will be connected between principal node and ground, K will be connected between principal node and ground. So what will you get? This is K and this is B. you can directly write here F is nothing but incoming force is equal to outgoing force. So I will write here for this mass it will be equal to m d square x by dt square plus kx plus b dx by dt. So this is the differential equation that you have got from this mechanical system. This equation is nothing but same, this equation is same that I have written here. So F is equal to m d square x by dt square plus b dx by dt plus kx. So first of all, what will you do? You will determine the number of state variables by identifying the order of the system. So for identifying the order of the system, you have to know, you should know what is the differential equation and what is the highest power of the differential equation. So highest power of the differential equation is 2. So the order of the equation will be, number of state variable will be 2. Now what are the state variables? I have considered here x is equal to x1 and x1 dot is equal to x2. Now you can write here d square x by dt square, x1 dot is nothing but dx by dt and this x1 dot is nothing but x2. d square x by dt square is nothing but x2 dot. So x2 dot is equal to, you can write here d square x by dt square is equal to minus b by m dx by dt minus k by m x plus f by m. Dx by dt is nothing but x1 dot and this is nothing but x2 minus b by m x2 minus k by m x1 f by m. So you can see here x1 dot is equal to x2 and x2 dot is equal to f by m minus b by m dx by dt minus k by m x. So you can easily find, you can easily write the state equations for two orders. So how can you write, how can you find the value of a, b, c and d? So we cannot find the value of a, b, c and d. I am interested here only for finding the state matrix or for drawing the state for writing the state equations. So I have already written here x1 dot is equal to x2, x2 dot is equal to minus b by m x2 minus k by m x1 plus f by m. So x1 dot x2 dot is equal to 0 1 minus k by m minus b by m x1 x2 plus 0 f by m u. So you can see here the value of a will be this and value of b will be 0 comma 0 f m. So we can write like this. So this is the procedure. How can you write the state equations for any given mechanical system? You can see here this has already written. Now let us take another example. In this equation, in this question, the transfer function is given to you. In the previous question, we have the mechanical system is given to us and we have derived the differential equation from the given mechanical system. After finding that, after getting the differential equation, we have found that the how we can find the state matrix or system matrix or input matrix and feed forward matrix. So this transfer function is given, TF is equal to 4 by s square plus 2s plus 3. So again the procedure is same. We have to find the differential equation by taking the inverse Laplace. So this is nothing but this is cross multiplication. Ys by us is given to you. S square plus 2s plus 3 multiplied by ys is equal to 4 into us. We have taken this inverse Laplace. So when we will take the inverse Laplace, we will get here d square y by dt square plus 2 dy by dt plus 3y is equal to 4u. Now, again I will consider here, because nothing is given to you, we have to consider, because this is the second order differential equation. So number of state variable will be 2. What will be the output? I have considered here y is equal to x1, dy dt is equal to derivative of this, that is x1 dot is nothing but x2. D square y by dt square is nothing but x2 dot. So what will be the value of this? I have already written here d square y by dt square, differential equation is this, plus 2 dy by dt plus 3y is equal to 4u, plus 3y is equal to 4u. So you can write here d square y by dt square is nothing but x2 dot. X2 dot is equal to 4u minus 3x1. x1 is nothing but y. dy by dt is nothing but x1 dot or x2. So you can write here x2 dot is equal to 4u minus 3x1 minus 2x2 by putting dy by dt is equal to x1 dot, d square y by dt is equal to x2 dot, and d square x by dt square is nothing but x2 dot. So by putting all these values in this equation, I can get x2 dot is equal to 4u minus 3x1 minus 2x2. Now from these equations we can write state equation and output equation. So x1 dot x2 dot is nothing but, you can compare here, you can write here 0x1 plus x2, you can write here 0 comma 1 minus 3 minus 2 x1 x2 plus 0 4 u. This is the state equation. What will be the output equation? You can write here y is equal to x1. x1 is nothing but x1 plus 0 into x2. So what will be here? 1 0 x1 x2. So this is the method how can you find the state equations or state matrices from the given transfer function or differential equation. So it is clear, if the transfer function is given to you, you have to derive, you have to find the differential equation from the given transfer function by taking the inverse Laplace. After taking the inverse Laplace, you can calculate, you can find the state equations and output equation. Now, how will you draw the block diagram? So you can see here, output is, again the output is y and input is u. So your input is ut and output is yt. Yt is nothing but x1 and x2 dot number of nodes. How will you find the number of nodes? Number of nodes will give the information from, you will get number of nodes from the order of the differential equation. So number of nodes are 2. So nodes will be this and this, or you can say, you can consider this also. The x2 dot ut is equal to, so what is the output? Output is yt is equal to x1. So for getting this x1, what will you do? You will differentiate, because variables are 2, x1 and x2. x2 dot x1 dot. For getting x1 dot from x2 dot, you have to integrate one time, and for getting x1 from x1 dot, you have to integrate one more time. So by integrating 2 times x2 dot, we can get x1. And what is the desired output? Desired output is that 4u, output is this, 4u is equal to d square y by dt square plus 2 dy by dt plus 3y. So here x2 dot is nothing but, x2 dot is nothing but 4u minus 3x1 minus 2x2. 4u minus, this is 4u minus 3x1 minus 2x2. So you will get here x2 dot. and after integrating all these things you will get x1. Now what is the relation between state equation and higher order differential equation? So if this is the differential equation of nth order, so you can write like this: d ki power n y by dt dtn plus a1 d ki power n minus 1 y by dt n minus 1 up to a n y is equal to ut. So the simplest method is that this differential equation is nth order differential equation, so number of node will be n, and you can consider n nodes. The procedure will be same. First I will consider here y is equal to x1, you have to differentiate for n times. After nth derivative you will get the output in terms of state variables, and the output will be x dot is equal to, this is the state equation, so you can write the matrices from this equation and all these equations. Now what is the state diagram? The significance of this state diagram is that it forms a closed relationship. So this is all about the state transition state variables, in which I have discussed the state equations and output equation. I will discuss state transition matrix in the next lecture. Thank you.